Hey guys, we're going to start working through the review for our fall semester exam. I do apologize that I was out today, but life happens. I was sick with the flu. I seem to be better, but I'm not 100%, but I hope to be in tomorrow. Alright, so number 1, a shop makes tables and chairs. Each table takes 8 hours to assemble and 2 hours to finish. Each chair takes 3 hours to assemble and 1 hour to finish. The assembler can work for at most 200 hours each week, and the finisher can work for at most 60 hours each week. Write the inequality representing the number of hours. Let T be the number of tables and C be the number of chairs. Okay? So, basically, we have tables and we have chairs. Okay? And we know that the assembler, we have tables and chairs, and we have assemblers and we have finishers. Okay? And it tells us that it takes 8 hours to assemble a table and 3 hours to assemble a chair. So you could say 8 times T plus 3 times C. So that's the number of hours it should take to assemble. Okay? Should equal to, what is the total number of hours that the assembler can work? At most 200. So first off, I'm using the wrong, I shouldn't be using an equal sign. I should be using an inequality sign. So at most means that he cannot work more than that. He can work less than that, but he cannot work more than that. So that means it's less than or equal to 200. Okay? So again, this equation came from the idea that it takes 8 hours to assemble a table and 3 hours to assemble a chair. Okay? And that the assembler can work for at most 200. Remember, at most means it's the highest number I can have. So that means that this side's got to be either equal to it or less than it. It cannot get greater than 200. Alright? So now we're going to talk about the finisher. The finisher, well, to finish a table takes 2 hours, and to finish a chair, it takes 1 hour. And it tells us that the finisher can work for at most 60 hours. So that's the same inequality, less than or equal to 60 hours. And there you go. It didn't ask us to solve for anything. It just asked us to write the system of inequalities. Okay? Number 2. For the function at the right, give the domain and range. So there's lots of different formats, but the one that I'm going to focus on is the interval format, which is parentheses and brackets, because that's just what you'll see the most. Okay? So, domain. Remember, that's the set of all x values, all possible x values, and range is the set of all possible y values. Okay? So let's do domain first. Domain. Now, remember, the domain is read from left to right. So we need to look at our entire graph. So here's our entire graph. It's this little loop thing right here. Okay, I'm not talking about the axes. When I say graph, I'm not talking about the axes. I'm talking about this little loop thing. Okay? What is the most left x value? Well, we see this little loop. Let's go to the left. What's the leftest it goes? Right here at -2. Since it's a closed circle at -2, we get to do bracket -2, comma. I now need to find the most right x value, which is 4. And that's closed, so it's also a bracket. Range is all possible y values from the lowest y value to highest y value. So when I look at my graph, I see that my lowest y value is -3, and my highest y value is 1. Since they're all closed circles, I can put them in brackets. And I'm done. That's all this problem asked me for. Okay. Number 3. Find 2 different ordered pairs in the solution set to the following system. Okay. So this is inequalities. So that means we need to graph these lines, and then we just got to look at where the shading happens. Okay. So first off, I genuinely apologize for this graph that I'm about to try to freehand draw. Okay. Let me try to slow it down a little bit. Let me try using a little bit of lines because there's no reason for me to rush. All right. So here's my y-axis. Here's my x-axis. However poorly done it is. Okay. So, y is less than -3x plus 2. That plus 2 tells me I start right here. And then I can go down 3, so 1, 2, 3. And I can go over 1, so there's that. I can go down another 3, so 1, 2, 3. And over another 1. So there's that. Wow, this is going to be a very, very ugly graph. Alright. And then, actually, you know what? Let's just pause doing this. If I was a better editor, I'd come back and delete this part of the video, but I'm not going to do that. going to tell you guys I'm just going to use a calculator. Alright, and I'm going to show you how to do it on a calculator. Because freehand graphing like this is just going to be ugly. Alright, so let me show you what you can do. You can go to y equals. Alright, now you'll notice that I'm typing under the assumption that y equals this. So I'm going to have to shade in my head. There is a way to shade on your calculator, but I find it to be largely not helpful for most students. So if you really want to know, feel free to ask me in class, but I'm not going to worry about addressing that here. Okay, so the first line we're going to see graphed is the negative 3x plus 2. The second line we're going to see graphed is the 4x minus 1. So here's the negative 3x plus 2. Here's the 4x minus 1. Okay, so the next thing is, come back. The next thing is think about, hey, this line right here, negative 3x plus 2, where would this guy shade? Well, it says y is less than that. So that means it's going to shade below this line. So that means all this stuff is going to get shaded. And this 4x minus 1, it says y is greater than that. So it's going to shade above all this stuff. So then I have to think to myself, where was the double shaded area? That was all right here. And all I asked for you to do, was to pick out 2 points that were in this double shaded area. So you could give me negative 1, 0, and you could give me negative 3, negative 1. I mean, there's tons of points in here. You could have also said negative 4, positive 1. You could have said 2, 2. Alright, there are tons of possibilities. So I'm going to do negative 1, 0, and negative 2, negative 1. But there are so many other possibilities out there. Negative 1, 0, negative 2, comma, negative 1. Okay. No problem. Determine the domain and range of the absolute value function y equals absolute value of x. So, again, I could try freehanding it, but it's going to look so ugly that I'm going to take a moment and just graph on my calculator, and then we'll talk about the domain and range for it. So I'm going to hit math, because that's going to go over to num, and that's going to bring up ABS. So if you're using a little bit more advanced calculator, what you actually get instead of ABS is actually the 2 straight bars, and now there's something blinking in between the 2 straight bars. So absolute value of x, I hit graph, and that's what it looks like. So first thing it asks us to do is determine the domain. So what's the most left this graph goes? Well, it actually is going to keep going up here because it's just like an arrow right here, and there's an arrow right here. Even though you can't see it, it is understood. So that means the domain is all real numbers, or negative infinity and positive infinity. So for the domain, I'm going to put all real numbers. But if you also put this, it means the same thing. Negative infinity to positive infinity, it means the same thing. Alright? So now let's talk about the range. The range is lowest y value to highest y value. Well, when I look at my graph, which is this V shape, I notice my lowest y value is happening right here. What is that y value? It's 0. And then I notice that I just keep going up. I know it goes up on both sides, but it keeps going up. So then that means the highest it goes up is positive infinity. So, for the range, I would write it like this. It goes from 0, bracket 0, to infinity. And I'm going to draw a funky looking symbol, but it's still inside infinity. And then you close that with a parentheses. Okay, and that's the domain and range. Next problem. Number 5. Solve the absolute value of 4x plus 6 is less than or equal to 30. So the first thing you have to do is get the absolute value by itself. Well, that's already done. I don't have anything else on the left side with the absolute value. So now, if you remember, absolute value means there's 2 equations. So I can set that up. I can say 4x plus 6. Oh man, my handwriting is bad. 4x plus 6 is less than 30. I'm sorry, less than or equal to 30. And then I can also say 4x plus 6 is greater than or equal to a negative 30. Alright, so let's solve for x in both of these cases. 4x plus 6 is less than or equal to 30. Well, we're going to start by subtracting 6. And the reason we do this is we want to get x by itself. So we do the opposite order of PEMDAS. PEMDAS would have me do any parentheses first and do any additions and subtractions last. So whenever you're trying to solve for a variable, you do the opposite of PEMDAS. So you need to get rid of any additions or subtractions first. So I subtracted 6. So now I have 4x is less than or equal to 24. Now I'm going to divide both sides by 4. And I get that x must be less than or equal to 6. When I come over here, I'm going to start off doing the same thing. Subtract 6. subtract 6. So I get 4x is greater than or equal to negative 36. Divide by 4. Divide by 4. And I get that x is greater than or equal to 9. And there you go. There's your two answers. Alright. Let's move on. Problem number 6. The domain and range of f are shown. The domain is the set x such that x is greater than or equal to negative 5. And the range is y such that y is greater than or equal to 6. Give the domain of the inverse. Remember, the domain and range of the original, you switch them to become the domain and range of the inverse. So that means the domain of the inverse is simply the range of the original. So here's the range of the original. So then that is the domain of the inverse. All you have to do is change y to being x. And there you go. Alright, let's move on. Problem number 7. For f of x equals 4x minus 8, find the inverse. Okay, to find the inverse, I'm going to do this with typing, just to try to make my handwriting a little better. Y is equal to, the first thing I'm doing is no actual solving. I'm just changing f of x to being y. Okay, that's all I did. Now, you should remember that the first step to solve for an inverse is to switch x and y. Alright? So x is equal to 4, y minus 8. So now I need to solve for y all over again. So I start off by adding 8. So I get x plus 8 is equal to 4y. And now I just need to divide by 4 everywhere. I'm going to switch to the pen again. So I'm going to have x divided by 4 plus 8 divided by 4 is equal to 4y divided by 4. So x divided by 4 is the same thing as 1/4 x. Okay? Because that's the reason I can write 1/4 x is because the understood number of x right here is a 1. So all I do is basically pop the fraction out to the side. So 1/4 x is the same thing as x divided by 4. Plus 8 divided by 4, which is 2, is equal to 4y divided by 4 is just y. And there we go. Okay, problem number 8. Joe had a tire rotation, oil change, and headlight replacement done on his truck, and the total cost was $99. That is cheap. Josie had a tire rotation, oil change, and paid $75. Jose had a headlight replacement and tire rotation and paid $59. Formulate a system of equations to determine the cost of each. Okay, it's not that bad. Alright, so Joe had 3 things done. It tells me that X is the cost of a tire rotation, Y is the cost of oil change, and Z is the cost of a headlight replacement, and for Joe, that cost him $99. Then, Josie only had a tire rotation, which is X, and an oil change, which is Y, and that cost $75. Jose had a headlight replacement, which is Z, and a tire rotation, which is X, and that only costed $59. Whoa, whoa, somehow I'm making mistakes all over here. Right there. And boom, because it says formulate system of equations. Here's your system of equations where now you could solve for the cost of each. We don't have to solve for each. It doesn't ask us to do that. It just asks us to formulate. So we're done. Problem number 9. Solve the system. What is the value of Z? Okay, if you remember correct, back when we did this, we used our calculator's matrices ability. I recommend you do the same thing. But in order to use your calculator's matrices ability, all your variables need to be on the left side in the same order. Okay? So let's do that. So 3x minus y is equal to 3z. I need to move this 3z over. Okay? So it's going to be 3x minus y. When you move a positive 3z over, you're subtracting it. So that's minus 3z. And now that's just simply equal to 0. 2x equals z. I need to move the z over. So I get 2x minus z is equal to 0. And then y equals x minus 4. You need to move the x over. The negative 4 can stay on the right side. but all the variables need to be on the left side and in the same order. Since x came first, I need to make it go first in front of the y. So when you move a positive x over, you're subtracting it to bring it over, so it becomes minus x. Now this y needs to go next. Is it a positive y or a negative y? It's a positive y, so I just say plus y. I didn't move the negative 4, so I just say is equal to negative 4. I grab my calculator. I'm going to use my calculator's matrixy ability. Okay, so I'm going to hit second matrix. I'm going to go over to edit. This is going to be a 3 by 4 because there's 3 variables, but there's 4 columns because you have an answer column. So and then I put the coefficients. The coefficient right here is a 3. The coefficient in front of this negative y is a negative 1. The coefficient in front of this negative z, in front of the z is a negative 3. And then the very last number is 0. So I plug that in. Alright, now, 2x minus z equals 0. The first coefficient is 2. There is no y, so the understood coefficient is a 0. It's just negative z, so I'll just put negative 1. And then I put 0. Okay, and then negative x means negative 1 coefficient. Positive y, plus y means a positive 1 coefficient. No z, so I just put 0, and this is negative 4. Okay, now you hit second mode to jump out. You jump back in. You go over to math. You scroll all the way down to RREF. There we go. And then you enter the matrix one more time. Enter the one you edited, which in this case was A. Press enter. This last column is your answer column. X is 1, x equals 1, y equals negative 3, z equals 2. So my answer is z equals 2. And that's it. That's all I was trying to do. Okay, let's go to number 10. Oops. Solve the system. Y equals x squared plus 2x minus 3. Y equals 7x plus 3. Okay, if you remember correctly, this is a parabola. This is a line. So I'm just looking for where the parabola and the line intersect. I'm just going to let my calculator do all the hard thinking for me. So I'm going to hit clear. I'm going to go x squared plus 2x minus 3. Oh, man, sorry about that. Minus 3. Press enter. 7x plus 3. I'm going to hit graph. Okay, it seems that they're going to cross twice. I know we don't see that other one, so this is kind of a janky problem, but we're going to hit zoom 0. What zoom 0 I'm hoping it'll do is it's called zoom fit, and I don't think it's going to do what I want it to do. Well, maybe it will. Yes, it will. Okay. So then I'm going to try to do this through trace, and hopefully trace will give me a nice number. Does not seem like it's going to give me a nice number. So here's a function we haven't talked a whole lot about in class, but shouldn't be too hard. You can hit second trace, and you see this word number 5 where it says intersect. Just get yourself really close to the intersection point, and then hit enter 3 times. Boom, that's where they first intersect. Negative 1, negative 4. So one of your answers is negative 1, negative 4. Excuse me. Okay, so now we're going to use that same feature to get this intersection as well. So we're going to hit second, trace, go down to intersect, and then we're going to scroll over to where we're as close to that intersection as possible. Okay. Okay, so I'm pretty close. I'm going to press enter 3 times. And my other intersection is the point 645. So 645. And there I go. So again, the two things that really helped me after graphing, so we did y equals, then we hit zoom 0, and then after that, we did second trace 5. Second trace, if I type, I probably would have been faster. Second trace 5. And then you just get as close as you can to each point and you press enter 3 times. Alright, let's go on number 11. This problem, number 11, is very similar to the problem that we just did. Okay? So once again, we have a linear equation and we have a parabolic equation. It means quadratic. It's going to be the shape of a parabola. and we want to solve. So basically, anytime you want to solve a system of equations, you're really just looking for where they intersect. So once again, we're going to let our calculator do all the hard work for us. So we're going to turn our calculator on. Okay, it doesn't want to turn on at the moment. Sometimes it's easier if I do that. Just restart it. Awesome. We're going to go to y equals. Plug in x plus 4. Plug in negative x squared plus x. Hit graph. Here's our linear. Here's our parabolic. What do we notice? What happened? They don't intersect. So therefore, there is no solution. No. I'm not going to write out the rest of that word. No solution. No solution because they don't intersect. Since they do not intersect, there is no solution. Okay? Alright, next problem, number 12. To the shaded area below, which is the solution to which system of inequalities? So we have a bunch of system of inequalities here, and we want to know which one of these matches up with this. Okay. So, first off, I went ahead and gave y'all 4 choices here because I want y'all to sometimes think a little bit outside the box. Okay? I want you to sometimes think about how can I just eliminate stuff real fast, okay? Well, first off, look at this green line right here. See this green line? It's a straight up and down equation, okay? What type of equation goes straight, what type of equation, yeah, what type of equation goes straight up and down? Is that y equals or x equals? Think carefully. It's an x equals. Because this is x equals negative 2. It's going to be x, the value of x all along this green line will always be negative 2. So that's why we know it has to be x equals negative 2, but there's some shading involved. So I mean it's an inequality. Which side did I shade to of this green line? To the right side or to the left side? I shade to the right side. Is that going to be getting greater for x or less for x? Greater for x. So it means x must be greater than negative 2. Now, this was a solid green line, so that means this x must be greater than or equal to negative 2. So then we can look at A. Do you see any x greater than or equal to negative 2? No. So we know we can mark out answer choice A. What about answer choice B? Do we see any x is greater than or equal to negative 2? No. So B is gone. C, x is greater than or equal to negative 2. And D, x is greater than or equal to negative 2. So we have 2 good choices, okay? So now you see the next equation is the same on both C and D. So I'm not even going to worry about trying to do anything with that equation. I'm going to go with this last equation, which is y is greater than or equal to 3x minus 4, or y is greater than 1/3 x minus 4. Okay, so let's take a moment and look and compare these two things. You'll notice this first equation from C must be a solid line. This second equation from C must be a solid line. This third equation from C must be a solid line. Look at D. This first equation is solid, this second equation is solid, but this last equation is not solid, is therefore dotted. Well, now go back to this original graph. I have 2 solids, 1 dotted. Which one gave me 2 solids and 1 dotted? C or D? D did, because it gave me solid, solid, dotted. Because remember, if it has the equal to bar, that means it's solid. So x being greater than or equal to negative 2 is solid. Y is less than or equal to negative x is solid. Y is greater than 1/3 x minus 4. Well, that's dotted. So I can mark out C, and it must be answer choice D. I know that's not the most algebraic way of thinking through this problem, but it is a helpful way of thinking through this problem. Anytime you have multiple choice, you should take advantage of the fact that it's multiple choice and try to use some deductive reasoning. Alright, let's go to problem 13. A parabola passes through 3 points. Find the function, okay, to represent that parabola. What is B? So B is the coefficient on x. Our calculator will do all this work for us. The way we do that is we jump out of this. We go to Stat, Edit. X is going L1. Y is going L2. So 0, 1, negative 2. Oh, I didn't press enter. And then 5, 3, and 15. Hit second mode to jump out. Go back to Stat. Go over to Calc, go down to 5, press enter again, and it just wants to know what B is. B is negative 3. So B is equal to negative 3. And there we go. 14. Solve 3x squared minus x minus 2 equals 0. Okay, so this is a quadratic function, so you guys should realize that we have 2 different ways of solving. We can either solve through tic-tac-toe, or we can solve through quadratic formula, whichever way you prefer. Now, be aware that it may not end up being factorable. I really don't know, okay? And in order to use tic-tac-toe, it has to be factorable. I'm going to go ahead and try to use tic-tac-toe. If it doesn't work, I'll switch to the quadratic formula. So, I draw myself my tic-tac-toe. I put my 3x squared here. I put my negative 2 here. Multiply the 2. Gives me negative 6x squared. Okay. Draw my little box. So I need two numbers that multiply negative 6x squared and add to negative x. Negative 3x and 2x. 2x times negative 3x is negative 6x squared. Negative 3x plus 2x is negative x. Now, 3x squared and negative 3x, what do they have in common? A 3x. 3x squared and 2x, what do they have in common? An x. 3x times what is negative 3x? Negative 1. X times what is 2x? 2. Go across, go across. So we get x minus 1, 3x plus 2 equals 0. Because all you do when you tic-tac-toe is just rewriting this equation into being two sets of parentheses. Now I can set each parenthesis equal to 0. So now I can set each parenthesis equal to 0. So x minus 1 equals 0. So I need to solve for x, so I add 1 to both sides. And I get x equals 1. 3x plus 2 equals 0. I subtract 2. I subtract 2 from both sides. So now I have 3x is equal to negative 2. Last step is to divide by 3. Divide by 3. Divide by 3. So x is equal to negative 2/3. And there we go. There are two answers. Okay. Next problem, problem 15. The equation takes the graph fx equals the absolute value of x and moves it up 5 units and left 7 units. Okay, so it just wants me to write a new equation because this was going to be a multiple choice problem. I just stole it off a multiple choice problem. That's why it's worded a little bit weirdly. But it just wants us to write the new equation, moving it up 5 and left 7. So, to move something left 7, I basically add 7 inside with x. I don't know why I just wrote a plus sign. Because remember that moving left is opposite of what you think. You might think minus, but it's actually positive. So x plus 7, close the absolute value bar, and then up 5 is just plus 5. Alright, that's all I have to do. Problem 16. Convert the function fx equal x squared minus 6x plus 11 into vertex form. And I gave you 4 multiple choice because I've taught you guys this problem through multiple choice. Okay? And there is an algebraic way of doing it. But really the calculator can do this for us if we have multiple choice. Okay? And what I tell you guys to do is I tell you to go to y equals and to plug in, clear out any junk you don't want, and then plug in your original x squared minus 6x x squared minus 6x plus 11, and then I tell you to plug in your answer choices. So x minus 6 squared plus 11. Okay, and I'm going to plug them all in at once because to me I just think that's faster. Oh. You're more than welcome to plug them in one at a time and compare that way. Really, honestly, whatever you think works for you best. Alright, so x minus 11 squared plus 6. That was B. Now I'm plugging in answer choice C. X minus 3 squared plus 20. And then x minus 3 squared plus 2. Alright, and then I'm going to hit graph. Here's my original. There's, could be A. And then I don't see anymore. So you could fiddle around with hitting zoom 0, and trying to mess with the zoom. Or you could just go to the table and look to see which table has the same exact one, the same y values. So y1 is the y values from your initial equation, the x squared minus 6x plus 11, your original equation that you're trying to find something in the same form as. Y2 is answer choice A. It does not have the same table, so we know it's not going to be A. Y3 does not have the same table as Y1. If you go back to Y1, you can see that. Y1 starts with an 11. 0, 11. Y2 was at 0, 47, so we know that's not the same as Y1. Y3 starts at 127, which is not the same as Y1. Y4 starts at 29, which is not the same as Y1. But Y5 does start at 11, which is the same. It's the only one that was the same, so we don't need to check any other values. We know that answer choice D must be our answer choice. Alright, number 17. Solve. 2x squared plus 9x plus 16 is equal to 0. So once again, this is a quadratic equation, so I'm going to try to start by solving through tic-tac-toe, but I have an inkling that it's not going to work this time, and I think I'm going to have to resort back to the quadratic formula. So 2x squared 16 multiply, you're going to get 32x squared. It needs to add up to be 9x. Okay, so you need two numbers to multiply to be 32 and add up to 9. So you start thinking, you're like, well, 8 times 4 is 32, but it does not add to be 9. And you notice this is positive, this is positive. Everything's got to be positive, okay? Because you need your two numbers to multiply to be positive and to add to be positive. All right, so you start thinking, well, maybe there are another two numbers less than 8 and 4 that add. And you think, I know 16 times 2 is 32, but that doesn't add up to be 9. And that's it. There are no other numbers that multiply to be 32 other than 16 times 2 and 8 times 4. Not that I can think of. So, tic-tac-toe this time is not going to work. So, I need to resort back to the quadratic formula, which the quadratic formula is x equals negative b plus, that's a plus sign, I'm so bad at writing, plus or minus the square root of b squared minus 4ac all divided by 2a. Alright, so what are a, b, and c? Well, a, b, and c just come from my equation. A is the number in front of x squared, so that's 2 for this problem. B is the number in front of x, so that's 9 for this problem. C is my constant number, so that's 16 for this problem. So first thing I do is I just plug in those numbers. So I'm going to get negative b, so negative 9, plus or minus the square root of b squared, so that's going to be 9 squared, minus 4 times a, which is 2, times c, which is 16, all divided by 2a, a, which is also 2. Alright, so now you need to figure out what's happening underneath the square root sign. So that's also called the discriminant. You need to figure out what's going on with the discriminant. Okay, the discriminant is what's happening underneath the square root sign. So 9 squared, notice I did not put square root. I'm not square rooting it yet. I'm seeing if I can square root it by first looking and seeing what the number is. Times 16. Press enter. And I get a negative 47. That's weird. Okay, well you're not going to get negative 47 on the test. I made this problem up, and I guess I should have made this a minus 16. Okay? And if you made this a well, we're just going to keep the negative 47. I bet what I meant to do was to make that like a minus 16 or something. But, for the fact of the matter is now we have a negative 47. So we're just going to go ahead and throw that underneath the square root sign, but you're not going to get that on the test. On the test, you're going to get a positive number. So negative 9 plus or minus the square root of a negative 47 all divided by 4. Now, if you could take the square root of negative 47, you would do that right now. But you cannot take the square root of negative 47. So we're just going to leave it as the square root of negative 47. And so this is as far as our problem can go because I cannot do anything with a negative square root, and 9 and 4 are not divisible, so I can't break the numerator up and reduce that portion. Alright? So that's your answer. Let's go on to number 18. Find the domain and range of the relation below. Alright. So remember, domain is simply the set of all x, and range is simply a set of all y. Okay? So my domain for this problem is, well, y'all notice this little dotted line right here? That's called an asymptote, and we talked about that before. It means it's a line I'll get infinitely close to, but I'll never touch. So considering if you look at my graph here, this dotted line represents the most left I'll ever get to go, but since I don't get to touch it, I have to put it in parentheses. And it's at an x value of -3, so it's parentheses -3, comma, and then you'll notice that my graph just keeps going on forever to the right. So -3, comma, goes to infinity, and then I draw myself another parentheses. Alright? So now my range. The set of all possible y values, remember it's lowest to highest, and you'll notice here that the lowest I seem to be getting to is 0, but I don't ever seem to actually touch the 0. Okay? It's because I get closer and closer and closer to it. This is from a calculator, alright? And so it's just hard to tell, but this is actually getting closer and closer to 0, but it's never actually touching the 0. So we do parentheses, 0, comma, and then my y values just keep going up forever, so that's infinity as well. Draw my infinity sign, draw my parenthesis, and there you go. That's all that's required. And just for a little tidbit, if you were to write, so this is the interval version of domain. The inequality version for domain here is x is greater than -3. Okay, because I'm getting larger than -3, I'm going to the right of -3. And the range is y is greater than 0. I just want you guys to be aware of the inequality version of this, okay? So really take a moment and kind of think through that. Alright, number 19. Now, number 19 is actually something we've never addressed in class, and so I'm actually not going to make you guys work on it on the actual test. I'm going to go ahead and address it in this video, but on the actual test, I'm either going to tell you skip it or I'm going to give you the answer because we've never addressed it in the class, okay? It says, use the graph to solve the inequality. X squared minus 3x minus 4 is greater than 0. Okay, this problem is actually not as hard as you think, considering they've already given you the graph. It just wants to know, where is this guy greater than 0? That's all it wants to know, is where is this guy greater than 0? Alright? And what it's talking about there is what x values make this greater than 0. Okay? Well, that means that we're looking at the x values for where the graph itself is greater than 0. Okay? So it means, basically, I've said this several times, but basically what the question is saying is, hey, what are the x values that make the y's bigger than 0? Okay? So y is larger than 0 here, and y is larger than 0 here. What are the x values that do that? Well, all of these x values make the y bigger than 0, and all of these x values make the y's bigger than 0. So basically, the x values coming from negative infinity all the way to -1 make it bigger than 0, and all the x values from 4 and to infinity make that true. So you might get two statements that look like this. X can be less than -1, because think about that. If x is less than -1, is this graph above 0? Is the y value above 0? Yes. So all the x values that are less than -1, if you were to plug them in, they would make this be a true statement. They would give you a value of larger than 0. So, if you have inputs that are less than -1, your outputs, which is your y's, are greater than 0. And think about all the ones where x is greater than 4. This is true as well. Okay? So, problem number 20. Solve the absolute value of 2x minus 2 is equal to 6. Alright, we've already done a problem similar to this, so it should take us no time at all. We just simply set up our two equations. 2x minus 2 is equal to 6. 2x minus 2 is equal to -6. The reason I could start it out like this is the absolute value was already by itself on the left side. There was nothing on the outside of the absolute value. So I set up my two equations, where 2x minus 2 is equal to 6, and 2x minus 2 is equal to -6. And then I solve for x by adding 2. So I get 2x is equal to 8. Okay, so 2x is equal to 8. Now I need to divide by 2 on both sides. So that gives me x is equal to 4. And then I do the same thing here. I add 2. So I get 2x is equal to negative 4. I divide by 2. I divide by 2. And I get x is equal to negative 2. And of course, you can always take a moment and plug these in to double check. So take a moment and plug in the 4. You get 2 times 4, which is 8, minus 2. So that gives you 6. And the absolute value of 6 is 6. So try with the negative 2. 2 times negative 2 is negative 4. Negative 4 minus 2 is negative 6. The absolute value of negative 6 is positive 6. Okay? So problem 21. Write the new equation for f of x equal to the absolute value of x with a reflection of the x-axis, right 4, down 7. Okay, so f of x, it just wants us to write the new equation. We did a problem like this earlier. A reflection is just a negative sign at the very beginning of the equation. To go right 4, it's just a minus 4 inside the equation with x, wherever x is, which in this case inside the absolute value bars. You put the minus 4 with it. And then down 7, so that's just minus 7. And that's it. That's all there is to problem 21. Problem 22. How has the graph f of x is equal to 7 times the absolute value of x been changed from the graph of absolute value of x? This 7 is multiplying to it. It's bigger than 1. So it has a vertical stretch of 7. Alright, problem 23. Solve x minus 1 is greater than 8. We just did a problem like this at the very beginning of this. I'll go ahead and do it again, but we just did one. You set up your two equations. X minus 1 is greater than 8, and x minus 1 is less than negative 8. You now solve for x by adding 1 in both cases. So add 1, x is greater than 9, add 1, x is less than negative 7. Now, just so you're aware of what it could look like on a test, they're not going to leave it spaced out like this. They're not going to say x is greater than 9 and x is less than negative 7. What they're going to write it as is they're going to say, okay, if x is less than 7 and x is greater than 9, is there a way I can write this combining these two? Alright, so they're going to write, No, they're actually going to write the word and because there's no way. If you think about it as a number line, you get a 9 here and a negative 7 here. Sorry about that. I said they wouldn't do that because I thought they were going to combine them, but you actually can't. Alright, so you put a 9 here and a negative 7 here. X has been greater than 9. Well, that'd be an open circle here at 9, and then going to the right after that. And x is less than negative 7. That would be an open circle here going to the left of that. So these two do not combine to make one, so they actually would write the word and. Alright, and you are going to see it on the test, so be aware of that. If they combine in the middle, you would actually make it one big statement. And I'll flip back to problem 5, I think it was, and I'll show you all that real fast after I finish 24 and 25. Alright, 24, multiply these two together. Alright, we should be masters of this by now, but let's go ahead and do it. 2 times 3 is 6. 2 times I is a positive 2i. Negative 7i times 3 is negative 21i. Negative 7i times positive I is negative 7i squared. Okay, a lot of you guys on the last test forgot that I squared is the same thing as negative 1. Okay, so I'm going to change this I squared to being negative 1. Alright, minus 7 times negative 1. Alright, so we get 6. I can put this 2i and this negative 21i together real fast. That's going to be negative 19i, so minus 19i. Negative 7 times negative 1 gives me a positive 7. So now I can put the other like terms, 6 and 7 together. So that gives me 13 minus 19i. And there you go. That's all there is to this problem. Last but not least, problem 25. Subtract x minus 8 minus all this. Guys, this does not mean multiply these two parentheses. Okay, that's not what it means. It means subtract. Okay, so first off, look at this first set of parentheses. Is there any reason for this first set of parentheses? No, so I can drop them. I'll just write x minus 8. Now, this second set of parentheses, when I want to drop them so I can start combining like terms, this negative sign will change the sign of everything inside this parentheses. So this negative 3x squared is going to become a positive 3x squared. Okay? This negative is going to make this positive 3x become a negative 3x. This negative is going to make this negative 1 become a positive 1. Now, I can put like terms together. It's best to start with a quadratic term, which is 3x squared. There are no other quadratics, so I just wrote 3x squared by itself. I'll now put my x's together. X minus 3x is negative 2x. And negative 8 plus 1 is a negative 7. And there you go. That's all this problem wanted. Okay, now I told you I was going to flip back to, I believe, problem 5 real fast. Because problem 5, yes. This was the absolute value one, and we had our two answers. X is less than or equal to 6, x is greater than or equal to 9. So if you think about this problem for a second, it says x must be less than 6, but x must be greater. Oh! I should shut up, because I just realized I made a mistake. Negative 36 divided by 4 is actually a negative 9. Alright? So that's good, because that's going to allow me to fix a small error and show you also this right here. Okay? So, if you were to put this on the number line, you go over here to negative 9, and x being greater than negative 9, or equal to it, is a closed circle with an arrow going to the right. Then, x is less than or equal to 6. So you go over here, 6, that's a closed circle with an arrow going to the left. Alright, so you notice how these arrows are pointing towards each other. So that means I can make this one big statement where it says negative 9, x must be greater than or equal to that, but it must be less than or equal to 6. So notice here, if you only look at this one half at a time, you get x is greater than or equal to 9. That's what I have here. X is less than or equal to 6. That's what I have here. I just saw that I can make it one big statement, and that's what it will look like on the test. Okay? Guys, I hope this video was helpful. Let me know if I made a mistake somewhere. Let me know if I need to clear anything up. Ask a lot of questions in class. Alright, thanks.